Welcome back, everybody. My name's Jim. I work at Neo4j. Yesterday, I was talking about the internals of complex systems like databases. Today, I'm going to be talking about how to use databases in combination with other cool components to build really compelling data systems. But of course, I'm a cheeky person, so I'm going to riff on this, right? The title of my talk is Lies, Damn Lies, and AIs, which is a riff on that old thing, you know, lies, damned lies, and statistics. Because you can prove anything you want with statistics, right? And I'm sure that AIs will also allow us to prove anything that we want. Okay, what's this? In English, yeah, I'd see that as cow. What is it in Canada? Thank you. I know that also as une vache from my schoolboy French. Cool. Actually, you're all wrong. That's not a cow. That's a drawing of a cow projected onto a computer screen, right? Yeah. But you see how easy it is in natural language with our fallible human brains. You kind of told me what you thought I wanted to hear. Right? That's interesting. So let's try this again. What's this? A picture of a dog protected on a computer screen. Yeah. But actually, if I showed you this, maybe that's not your dog exactly. Maybe you have a different dog, a fluffy dog, a big scary dog, or whatever. But we're kind of now in the same ballpark, right? Dog is what we're thinking about. Cool. So let's try this one. What's this one? Duck? Rabbit? Wow, there's some schizophrenia in this room. Wait, what? Actually, I'm not sure. But it turns out, you're both right, it's both a duck and a rabbit. But context plays a part. It turns out in those societies that celebrate Easter, in the autumn or the fall, as the Americans would call it, because ducks migrate, we would tend to think of this picture as a duck. Around Easter time in the Christian calendar, you tend to see that as a rabbit because you're bombarded by images of the Easter bunny, right? So context, the lived context that you're in, actually biases your brain towards seeing that picture in one way or another. Hello, Steve. So you see that in the fall, in the autumn, right? Whoops. Okay. 2 most used letters in the English language, right? Okay! That woke a few of you up. But that was the same words. Okay. Yeah, okay. You hear that a lot in software, right? Well, and that doesn't mean okay. That means what you've just said is the dumbest thing I've ever scraped off my shoe, right? So there's a lot of context here for those words. In fact, okay does have several meanings, right? It could be that I'm mad with you. It could be that I agree with you. It could be that your idea sounds good. The same letters could be that your idea is ridiculous. And context plays such a strong part in our communication. And it turns out, if you study this, more than half of the communication that we do as humans when we're using natural language is in the posture of our bodies, our body language. If I look mad at you, please don't photograph that, Steve. Then the context within which you receive that information is different from when I look pleased to see you. Yeah, it's not a facial expression you see often on me. Right, Neo4j colleagues? Yeah, absolutely. So the rest of it is tone of voice. Yeah, over a third of the way that we interpret information is by tone of voice. Right? If you hear my voice is then you interpret that in a kind of aggressive posture. If my voice is mellow and chill, you interpret that quite differently. And only 7% of the information content is actually the words that I'm speaking. That, to me, is insane, right? Because, you know, as a speaker, I have to use words. They're my tool. As software professionals, when we're communicating or programming, words are our tool. And it turns out that the words, or the programming language syntax, are the minority of information that we transmit. Weird, huh? So that's weird. Let me tell you something else that's weird. I'm thinking about apples. Yeah. Of course, what we can see on the screen here is a picture of an apple tree. But when I think about apples, I've got the world's crappiest apple tree in my garden. It's like yay high, and it rarely fruits. But when it does, the fruits are inedible, and the wasps eat them, and that's fine, right? They are wasp-grade apples. Except last year, 2023, it fruited really well, and the apples were really nice. And I don't often get I live in a city, so I don't often get the ability to have really fresh fruit from the tree. And that's stuck in my memory, right? That's a weird thing to say, but it's stuck in my memory. And I'm trying to convey to you, maybe when you think of apples, you think of something different. You think of your local fruit market or whatever, or what you had for breakfast. But that's my abiding memory when someone says apples to me. But you're not getting the same fidelity that I am. I have a really high fidelity model of that apple tree and the joy of the bloody thing finally fruiting and me being able to pick apples off it and eat them and share them with my neighbors who are fed up of getting apples. You're not getting that. You're getting the 7% version of that, right? You're getting the low fidelity version because I'm having to use words to transmit this to you. Now, maybe I'm a good speaker and you get 10% because I'm good with body language and all that kind of stuff, but you're not getting the thing that's in my head. So one thing I could do, I could write down an essay. I could write a beautiful essay about my apple tree. I know you thought you were coming to a tech conference and you've got some bloke down the front yakking on about botany, right? Bear with me. I could write it down and I could publish that essay about my apple tree on the internet. And in fact, I could even spread it across the whole internet. But the problem is it's the same low resolution version. It's a kind of derivative of a derivative that we end up publishing on the internet. Hold that thought. Let's talk about large language models. Let's talk about generative AI. So I've completely failed to convey to you the high fidelity image of my apple tree, right? We know that I'm not able to do that physically, right? So let's pause for a second and think about LLMs. Maybe they can help. Well, LLMs are amazing, right? Even as a sensible computer scientist, I still think that LLMs have the spark of something almost like life, almost like intelligence. I know they're not. I know that they are great at predicting following bytes given preceding bytes, right? They're a probabilistic engine for doing that. And they're awesome at NLP. Some people are claiming that they can pass the Turing test for AGI, right? I'm not skilled enough to choose that. But they're a closed box system. You don't know how they work. And they're probabilistic. They're not deterministic. So they kind of have this, they might predict what you want or they might not. Once upon a time, there was a apple. Thank you, John. There were several apples, in fact, so maybe I did a good job. But actually, the predictive text here is going to be based on what we've trained the LLMs on. And of course, what we have is this low resolution text format that we've spread across the internet, a pixelated, terrible picture of the high resolution of my Apple experience. That's a funny word to say, isn't it? Apple experience over the internet. And then we go ahead and we train our machinery on it, we train our models on it. Right? This cannot lead to an entirely good outcome. In fact, I can demonstrate that to you. LLMs, this is me talking to an earlier version of ChatGPT. This is ChatGPT 3.5, based on some work that Yejin Choi did. And Yejin Choi, we'll come back to her, but she's a genius level researcher based out of Washington, University of Washington in the States. And if it takes 5 shirts, 1 hour to dry in the sun, how long will it take 10 shirts? Any ideas? Oh, this is great. This is India, where you all do mathematics from an early age. When I ask this question in Europe or North America, half the audience says 2 hours, right? I think as a first approximation, 1 hour is correct. Yeah. Of course, you're smart engineers, so well, Jim, it depends on how big the line is. It's going to depend on the time of day. Is there going to be any shading? You're going to start, bullying me for requirements, right? But what will ChatGPT say, or early version ChatGPT? Not only does it lie to me, it says it will take 10 shirts, 2 hours, it doubles things, but look at this compelling reasoning here, right? It's trying to bully me into believing it's bullshit, right? And if I wasn't, if surrounded by such genius level mathematicians, then I might believe this because this is compelling, right? I can imagine my mum, I've used my mum before in this conference, I can imagine my mum reading this and saying, well, I'd better get the laundry on a bit earlier because it's going to take twice as long, right? It's compelling. This is an example of LLMs, right? It's the Boris Johnson problem. People call it hallucination. That's far too polite a word. This is Boris Johnson. He's a former Prime Minister of the United Kingdom. And he is a demonstrable liar. He's the only Prime Minister that's ever been convicted of crime whilst in office, and he tells lies. Now, whether you like him or loathe him, there's something really interesting about him. When he was accused of lying, he looked pained and anguished, like he genuinely doesn't know that he's lied. Even though he's full of bluster and bullshit and Latin, he looks genuinely hurt when he was accused of lying. And that's what LLMs are like. They believe what they produce. But we shouldn't. We know that these closed boxes behave in a certain way, so we should take it with a pinch of salt. So let's give it an easier question. This is my boss at Neo4j. This is Emil Afram. And I've known Emil for a long time. I know I've known his wife since before she was his wife. So you could ask ChatGPT, like, who's Emil married to? And it gives you the answer, right? This is much more sensible, right? Emil Ephraim married Joanna Ephraim in 2011. Perfectly believable. Joanna is a very Swedish name, common Swedish name. And so, yeah, absolutely, that's right. Yeah, we'll be better with that. Or are we? Actually, Joanna Ephraim is Emil's cousin. Right? Now, I don't know what goes on in Sweden, but I'm pretty sure it's not that kind of stuff. His wife is called Madeline, and she's definitely not his cousin. Right? But ChatGPT tells me that my boss is married to his cousin, which is awkward, right? Imagine a pay review where this comes up. So what do we need to do? What if computers could relate concepts in a more associative, deterministic way, like our brains do, right? So provide that kind of context. And in fact, they can, using a structure called a knowledge graph, which is a purposeful creation of a network of facts that we can reason about, a curatable, transparent network of facts. And this, of course, is not a new idea. In my reading of it, this stuff emanates back in the sort of sadly failed world of the semantic web, but it was repopularized by Google in 2012 and in the famous Things Not Strings article. And the idea between things not strings is that you've seen this, right? This is a Google search for NASA. So I type NASA in here. And I get the normal Google stuff here, but I also get this box here, like this knowledge box. And this knowledge box is a bunch of facts that Google have been able to derive from their knowledge graph. So if you zoom in, you get much more interesting stuff, right? It was founded in '58 under Eisenhower. I didn't know this. Its headquarters is in Washington, D.C. I thought it'd be somewhere cool, like Cape Canaveral or Houston, as they say. Not. And there's something about video games that it's published. Also did not know that. How does that look to computing professionals? Well, it looks like this, right? The underlay for that knowledge box is a graph of facts. So I can see here that this is a chap called Bill Nelson, who was the boss of NASA, which was founded by Eisenhower. And Armstrong worked for NASA, and he worked on the Apollo project, which was one of the NASA programs, which used Saturn V rockets, which is kind of nerd cool, right? And the objective was the Earth's moon, right? And of course, this is a highly simplified, presentation-friendly version of a knowledge graph. But you can see how we construct these, right? Facts connected by associations or relationships. And of course, in Neo4j, this is what we do in our daily life. We make sure that these kind of knowledge graphs are very accessible to you. We have simple idioms, nodes, relationships, and properties, right? Simple model. You don't need to learn first, second, third, Boyce Codd normal form just to get going. You've just got a bunch of facts and you can start interlinking them. Now, of course, this doesn't just apply to moon landings and fancy things like NASA, although NASA do have a knowledge graph built on Neo4j, I hasten to add. You could build a knowledge graph out of your commercial transactions because you want to use that to investigate your previous sales or make recommendations. You can keep a graph, in fact, where Neo4j came from was customer relationships, right? Which is a highly associative field, which is actually very difficult to decompose into flat tables. You could build graphs of digital twins, maybe of your data center or maybe of the physical infrastructure of the building that you live in, and be able to reason about where your data center is going to fail, whether hackers have penetrated it, or indeed, as in New South Wales, Australia, whether the building is going to wobble dangerously. Well, we don't talk about that, do we, Ozzy? No, no, no. And you can do things like products and parts. And the thing is that knowledge graphs help us as data professionals answer big questions. You can figure out what's important in a graph by analyzing the centrality or importance of a node. We did this actually in London. So London, has the famous tube network. And I guess many of you have been to London over your careers. Which station in that network do you think is the most important? If you had £1 to spend on maintenance, where would you put that pound? Charing Cross, good call. You're close, actually. Any other offers? I would think it'd be some of the big stations like Waterloo or Paddington, something like that. It turns out that doing a network analysis, it's Green Park. Does anyone know Green Park? No, it's not. Okay, few people do. It's not very famous. It should really be called Buckingham Palace, right? Because that's where it is. And Green Park is kind of an unimportant station. Only 2 lines go through Green Park. A lot of tourists, right? But not very infrastructurally very important. But if Green Park goes down, the ripple effects of that problem permeate through the network worse than any other station, even the big connected stations. So we can start to understand the importance of our network. We can start to understand what's unusual. We have the Combank in Australia who have a security digital twin, and they noticed some unusual activity, so they called the actual InfoSec team. The InfoSec team said, who are you? Well, we're the network monitoring folks. How did you know we were running an exercise? So they actually caught their own ethical hackers. And in fact, you can look at what's next. First thing I ever did in Neo4j was make recommendations for the next best action, for the product you should buy, for the route you should take, and so on. And we can build this, right? We can build this, or at least superficially build this right now here in this forum. So we're going to build a support forum, and our knowledge graph in a support forum starts with these important things. We have users who ask and answer questions, and we have tags so that we can navigate it, right? And we can turn this into a knowledge graph trivially. These things have properties. Questions have titles, they have a question in the body, and they have a link. Users have a name, and they have a reputational score. Is this guy giving me a good answer or a bad answer? Answers can be accepted, and they have a body text, and we have a tag so that we can create a kind of taxonomy. But these things are related, right? Users both ask questions and provide answers. Answers are associated to questions, and questions are tagged with various disciplines so you can find them. And in fact, doing that, you now have your own knowledge graph, right? Now, of course, in reality, yours may be more sophisticated than this, but the same simple idioms, nodes, relationships, are the fundamental building blocks. Nowhere here did I give you a mathematical smackdown about the relational calculus, right? It's really as straightforward as this. It's a high fidelity system that allows you to address the inherent complexity and associativity of the real world. But of course, you folks are here because it said AI in the title, right? You didn't want to come and learn about apples. You want to come and learn about AI. So now what? How do I stop my LLM from hallucinating? How do I stop the Boris Johnson problem? I've got one word for you, RAG. Well, okay, it's 3 words. It's an acronym. Retrieval Augmented Generation. Let me give you the crash course. So RAG today is the best way of giving an LLM-based system access to your organization's data, either because you don't want your data to be used to train an external LLM, or more typically, because you want the LLM to be augmented by real-time data. Remember, LLMs are trained. Now, if I remember English correctly, that's past participle. It happened in history. So by definition, your LLM does not know the current up-to-date data, right? It doesn't know your inventory, for example. So we need some way of bringing together live systems and historically trained systems. As developers, RAG is all about us. It is an architectural approach, a framework that treats different pieces of a system as components that are pluggable. So knowledge graph may be a part of that, your LLM may be a part of that, along with other things that you plug in. And more importantly, it's easy to get started with now, right? This isn't some fancy future-looking thing. This is already happening. And the way it works is that you have your app. The user asks a question, which gets vectorized in the embedding generator. That vector can be used to help enrich prompts on the way in to the LLM, should you so choose. The LLM receives your query, gives you some fantastic, creative text back from that, along with embedding vectors. We pop back into the knowledge graph, and the way we use the vectors is that we use them to resolve nodes in the knowledge graph, and then we can explore the neighborhood of that graph to check for accuracy, validity, and to enrich the content of the response from the LLM before we go back to the user. Now, I'll point out, I've used the term vector a few times there, right? And many of us have heard about vector databases in combination with LLMs. Vectors give you the dots, right? Vectors give you access to a geometric space. But if I come back to apples, without belaboring the point, if I was doing a query about apples with a vector, I don't know whether my apple is a fruit, whether it's a technical company, or whether it's the Beatles record label, right? Geometry doesn't give you that rich context. We want to drop out of the geometric space because ANN or KNN in that space is very loosey-goosey, it's not very accurate. We want to drop into a graph. Now we're in the space of topology, where we really can reason about whether things are in the same graph neighborhood, or indeed whether things are similar, even though they're a long way away from each other in the graph. The graph is deterministic, it's curatable, it's transparent, and we can use that to add context that vectors simply don't have. So if we think about that today, what things can we ask about a RAG-based system? We can ask what books I've written. That's historical data. That's in there. You can ask, do we ship to Bangalore? Maybe. That's been historically trained. Maybe not. Maybe that's a live system. But we can't ask how many books do we have in stock. Right? We have to bring live data into the mix here for the LLM. To develop a centric architecture, right? So models can be brought and downloaded. We've got models that can be trained locally. And we've got middleware, things like LangChain, that are going to glue this all together. And if you're interested in doing this, perhaps one of the easiest ways to get going is the folks at Docker built the Gen AI stack for developers, right? So you've got the middleware that glues this all together, enable you to plug in models of your choice, as well as your knowledge graph, in order to build a complete end-to-end system. So zap that QR code if you're interested. It's the kind of thing that will get you going in very short order. So my contention here is that we've got a left brain, right brain kind of thing. My colleague Steve will talk more about this later this morning. But the LLMs are amazing because they have that spark of creativity, right? I'm genuinely still amazed when I talk to an LLM. And even if it gives you back nonsense, the fact that the nonsense seems almost like a slightly drunk human wrote it, it's just amazing. But we need to balance that. We need to balance that probabilistic approach with a deterministic approach. We need to balance that opaque approach with a transparent approach. And knowledge graphs give you that. They give you the explainability, the accuracy, and the facts that you can use to ground the LLM so that you can get all of the benefits of the LLM without so many of the side effects. And this graph rag thing is happening now, right? This isn't just some marketing thing that Neo4j is doing. In fact, other people are doing this. This is a paper from some folks at data.world, and including Juan Secredo, who's a very famous person in this field. And they built a RAG system using a SQL database. And they found that with the SQL database and RAG, their accuracy improved by 16%. So that's okay. They built the same system again on top of a graph, and their accuracy went up by 54%, right, with the same data. Microsoft, you may have heard of them. They are doing this thing called graph RAG. What they do is they ingest their data, their text data, and they use their LLM to generate a knowledge graph. And they then deploy the knowledge graph and the LLM that generated that knowledge graph together. And they find, and so then what they do is they apply to the knowledge graph a hierarchical clustering. So they curate that knowledge graph. And then they find, excuse me, that even though that knowledge graph was generated by the LLM, when they use them together, accuracy skyrockets. So this pairing, this curated knowledge graph gives you better results all around. So these things are happening. It's happening. KGs, knowledge graphs, and LLMs are better together. I think this is a classic pairing, right? This is peanut butter and jelly, as the Americans and say, or idli and sambar, as we'll say here, or toast and marmite, as I like back home. Right? This is the pairing that's going to see us through the next generation of AI apps. But if I look into the future, I'm going to come back in my closing to wonderful Professor Ye-Jin Choi at the University of Washington. And she and her team have done some amazing work on trying to stop LLMs from hallucinating. One of the things they do is Euclidean reasoning. So they ask questions and they ask the reciprocal question of an LLM to try to uncover where the LLM gets it wrong. So the question here is, if you travel west far enough from the west coast, you will reach the east coast, question mark. And the answer here is true, because the earth is round. If you're traveling any direction long enough, you'll eventually come back to where you started. Here, same question. If you travel west far enough from the west coast, you will reach the east coast. Here, the LM gets it wrong. You can't reach the east coast by going west. Well, of course, you know, in a European frame, Columbus told us that was wrong, even though he also got it wrong because he thought he was landing in this country, right? Dope. So you can start to get the LLM to talk to itself, and you can notice where it gets things wrong by asking the question and the reciprocal question. And where are you going to store the results of this, do you think? Well, you're going to store these results in a knowledge graph, right? I think one of the things that Choi has also done is rather bravely decided to take on the idea of common sense in computing, which is a very brave thing to do, right? Because as humans, we get this. You can leave the lounge door open, but you can't leave the fridge door open. Now, that's obvious to you, right? There's a gentleman here nodding like, yeah, I meant, like, we're on the same wavelength here, right? You can't leave the fridge door open, right? Especially here, this is a very warm country. You leave the fridge door open, your food is going to spoil. You leave the lounge door open, your food is still fine, right? It's so hard for computers to understand that. But we can, again, start to solve some of this stuff with knowledge graphs. And one of the important things that Choi has pointed out is that language models are not knowledge models. It's much understated, right? But an LLM is not a source of knowledge. It's a source of generating language. Knowledge comes from the knowledge graph, and you pair them together. So what Choi did in her experiments was that she created a knowledge graph of all of these common sense and less commonsensical things, and was able to build a model where mostly computers could act in line with common sense. Another LLM and knowledge graph thing. And in fact, they found that in doing so, that they were actually able to improve over the baseline GPT-3 model. But what I think is really interesting, I think something that us as data engineers, where we're going to go, is this idea of symbolic knowledge distillation. Fancy term, but it really means we can make better models, better, smaller models from larger, worse models. And so what Choi and her team do is they take a big model, something like ChatGPT, and they make it talk to another AI. And the AIs have a conversation, and the critic AI kind of finds contradictions in the large model. And it distills a smaller model, and you will be unsurprised to hear that that smaller model, again, is a knowledge graph, a network of facts, which is then used to train a smaller model here. So we go from this big model, which is larger scale, bigger, with lower accuracy, to a model through the critic and a knowledge graph, to a model with larger scale and higher accuracy. This is almost science fiction to me, because there should be so much entropy in here. How can you make a better model from a worse model just by having the model talk to itself? Well, by distilling the facts and contradictions into a knowledge graph. I think this is important because what it shows is the future of our data pipelines will involve knowledge graphs, at the very least as an intermediary step, but most likely as part of the serving platform. So let me leave you with this. By 2025, half of Gen AI initiatives will have improved reliability and transparency by combining deep learning models with knowledge graphs. This is the way that Gartner are telling us that the industry is trending. I think that's very important. Gartner are a conservative organization. They don't bet on fanciful things. They don't bet on sci-fi, right? They bet on sure things. So this is happening. If you're interested, we do run a graph database meetup here in Bangalore. Interested, scan the QR code or come to the Meetup BLR website. Thank you all for being a lovely audience today. If you have any more questions, feel free to come chat with us at the Neo4j booth. Thank you very much.